Hi, I'm Josep Girart from the Institute of Space Science. I'm presenting the poster of the VLA Orion A large survey that is being observed. This configuration we started last year. This is the goal is to try to characterize the radio emission over a large sample of young stellar objects in the Orion A molecular cloud. For that, we have covered an area of 1 degree times half of degree around the Orion Nebula. In that area, there are more than 1,600 young stellar objects, and the idea is to characterize the radio emission. For that, we observe at two frequencies, 6 gigahertz and 15 gigahertz, at an angular resolution of 0.3 arcseconds. So that's 120 astronomical units with a sensitivity of 3 microjanskis. So that's very deep observations. The observations are being taken now. We have already 80 hours observed at 6 centimeters. And now we have like 50 hours observed so far. Still, we have like 80 sources. So thank you very much. My poster is 24.
Hi, I'm Marcello Giroletti from INAF in Bologna, and I will talk to you about this poster on RS-Ophiuchi that went off in 2021. What you see here is one of a set of 10 EVN and Merlin images. What I would like to point out is that there's a bunch of important physical questions that you see at the bottom, shock acceleration in these kind of sources, what is the geometry, and what is the profile of the circumstellar density. But the very important thing is that these are rare events. The last time this source went off was in 2006, so before we had the possibility to observe at high or very high energies, and in this case this occurred, and the next time this event will happen, we are very likely going to have both the SKA and the NGVLA, so we will understand even more next time. Thank you.
Hi, I'm Alex Hill from the University of British Columbia Okanagan campus. I have a poster about the Global Magnetoionic Medium Survey, which is a project using telescopes from around the world, north and south, to map out diffuse polarized emission from the entire sky to using the range of frequencies, so 2 octaves of frequencies necessary to map out the 3-dimensional structure of the emission from the Milky Way. This is a project involving a number of people who are here. So my poster is over across from the registration desk, and we have demonstrations of the use of this technique to map out the structure of the magnetic field in the Milky Way, identifying large-scale structures, and also the newest maps from the Canadian Hydrogen Intensity Mapping Experiment applied to galactic emission. So come check out the poster.
Hello, my name is Andrew Hughes from the University of Alberta. So for accretion-powered jet physics, one of the most important modern events that happened occurred in 2015 when V404 Cygni, a accreting stellar mass black hole, went into a bright outburst. Due to the source's Jansky level flux density, the VLBA was able to take short timescale imaging that revealed bright flaring and spatially resolved jet ejections. Furthermore, joint VLA monitoring showed that the polarization properties evolved on similar timescales, except the source is very weakly polarized. This weak polarization hindered our ability to draw strong physical conclusions because we could not resolve it spatially with the VLA nor detect it at VLBA sensitivities. So my poster at P31 with 2 sigma confidence addresses this and shows how the next generation telescopes will fix that. Thank you.
Hello, my name is Emilia Järvelä. I'm a Dose Family Prize Fellow in the University of Oklahoma, and my poster is about narrow line Sirius 1 galaxies, or NLS-1s. That's our class of unevolved HEN. And despite their low black hole masses, a fraction of these sources are actually able to host relativistic jets. And in order to find more such sources, we started monitoring a bunch of them at 37 gigahertz. And to everyone's surprise, we were actually able to see blazer-like radio flares in a bunch of sources that were previously classified as radio silent or radio quiet. We did a follow-up with the JVLA, VLBA, Effelsberg, and the Ovens Valley Radio Observatory telescopes, and the situation turned out to be way more complex than what we expected, as it seems like variability of 3 orders of magnitude is required to explain the high frequency behavior. If you want to know more, my poster is number 32. Thank you.
Hello everyone. My name is Ryo Kato, and I'm a postdoc of Kumamoto University and Osaka Metropolitan University. Title is Accuracy of Source Location Estimation for Gravitational Waves with Pulsar Timing Arrays. Gravitational waves between the Earth and the pulsar can be observed at the delay of the pulsar arrival times. We found that the source location could be determined by observing the pulsar distance with accuracy of the scale observations. In order to detect electromagnetic and gravitational waves from the source, it is important to know the exact source location. Thank you.
Hi, my name is Amanda Kepley. I'm on the NRAO scientific staff. If you're interested in how dense gas in a variety of nearby galaxies connects to star formation, please come see my poster at P36. Thank you.
Hello everyone, and my name is Kohei Kurahara, and I'm postdoc researcher from National Astronomical Observatory of Japan. And yeah, my poster is about our UGMRT observation results of an early stage merging galaxy cluster. And we achieved an image dynamic range of about 40,000, so using DDC method. And as a result, we found we could detect a diffuse radio emission for the first time about this source. And my poster number is maybe 38, so yeah, please come, come and see. Thank you very much.
Oh, okay, so this is, Tony referred to this earlier. He fortunately did not give out my home phone number, but we're on the left. We want to get, do I have it? Yeah, left, and we want to get to the right. We want no magic involved. The poster, I've had a bit of trouble getting it printed, but the gist of the poster is the NGVLA Transition Advisory Group has been working hard to develop something we call a matrix, which is a set of science cases that the VLA or the VLBA execute today, and then a set of technical options. How do you go from the left to the right? What could you possibly do the way that Tony said? And so the real reason I'm here is if you have thoughts about the impact of various technical options, corral me at coffee or at the reception this evening or something. I want to hear your thoughts, or on behalf of the Transition Advisory Group, I want to hear your thoughts. And I can tell you already, Tony's project manager hat of let's stop it on stop VLA and VLBA on day one. There's no appetite within the Transition Advisory Group for that.
Hi, I'm Bradley Meyers. I'm a postdoc at Curtin University in Western Australia, and I'm leading the effort to move forward the SMART pulsar survey with the Murchison Wide Field Array. As you could probably tell, there's 3 boxes on this slide, and probably can guess the pulsar search is actually a lot more complicated than that, but we have indeed found pulsars. So if you would like to come and see how we did that, the challenges we faced and the challenges we're going to be facing soon, then please come and see me at poster number 48. Thanks.
Hi everyone, my name is Chris Merkel. I'm a graduate student at University of California, Berkeley, and I use radio telescope to study the composition and dynamics of the giant planet atmospheres. And I'll be honest with you, my post is a little bit of a trap. I'm trying to trap you with these gorgeous radio images of the subcloud structure on the giant planets. So on the left here you see Jupiter. There's a whole range of like atmospheric processes shaping Jupiter's atmosphere. On the right, if you look in the center, you see the hexagon on Saturn, meaning it's extending below the clouds. And I'll also trap you with a promise of what NGVLA and SCAR will do for the study of giant planet atmospheres. But I will leave you with a bunch of open action items and challenges that we need to overcome to actually realize these next generation telescopes. So if you want to talk solar system science, come by P50 all the way over there. Thank you.
Hey everyone, my name is Ned. If you want to talk about solar system science, come to poster 50. Chris's is poster 49, because mine is poster 50. I have a couple interesting use cases in addition to what Chris said, and also what Catherine and Brian did a really good job of this morning, including the rings around Uranus and some stuff with Io. If you don't care about solar system science, please still come talk to me. One thing that I think is really interesting about imaging these targets is that they come up with some fascinating challenges on the algorithm and software development side for how you actually get beautiful images of very faint things near bright sources with sharp edges. And so I think that's something that is maybe more universal here. So anyway, come see poster 50 and also poster 49.
Hi everyone, my name is Kristina Nyland and I'm a staff scientist at the Naval Research Laboratory in Washington, DC. And my poster is on known quasars with newborn jets that were discovered by comparing multi-epoch radio survey data from surveys such as the VLA Sky Survey and historical surveys taken 10 to 20 years earlier, such as FIRST. So by modeling the radio spectrum with dedicated follow-up multi-frequency VLA observations, plus folding in some new survey data from LOFAR, we're able to actually place constraints on the triggering timescales of the jets. And we're finding that the jets are triggered on timescales of about 100,000 years at cosmic noon. Now, there are lots of opportunities for NGVLA synergy as well as SKA synergy. These two telescopes will really revolutionize our understanding of the life cycles of AGN. If you'd like to learn more, please come see my poster. It's number 52, and I hope to talk to you either in person or on Slack. Thanks.
Hi everyone, I'm Oscar O'Hara, a second-year PhD with the University of Cambridge. With the 21 centimeter signal being about 5 orders of magnitude below the foregrounds, and SKA proposing a cable between the low noise amplifier of the antenna and the smart receiver. Because of impedance mismatches, we get cable reflections. Me and my collaborators have designed a pipeline to propagate these reflections to the delay power spectra in order to quantify their contamination of the EOR window. If you want to find out more about that, I'm poster 53. Thank you so much.
Hi, my name is Rikuto Omae. I'm a PhD student in SOCAN and NOJ. I'm interested in the observation of magnetic field in distant galaxy. To observe distant galaxy, we focus on the Lens galaxy, rotation measure of Lens galaxy. Some polarization all-sky survey has started with STAT, POSAM and BLAST plots. These surveys are expected to detect polarization source affected by the gravitational lens effect. So these surveys cannot resolve polarization source, especially. So we investigate whether it is possible to resolve the distinguished voltage meter component each pass. Thank you.
Good afternoon, everybody. I am Kiyoaki Omori, a third-year PhD student at Nagoya University, and my poster title is The Merger Identification and Investigation of Radio Galaxies in HSC SSP VLA in FIRST. So galaxy mergers are a very important process when it comes to galaxy evolution, and they can be attributed to many processes such as star formation, AGNs, black holes, quasars, and these are observable at various wavelengths. So while my work is mainly in the optical, it can very much be applied to other wavelengths, such as the radio. So in this work, we classify galaxy mergers in the Subaru survey using a machine learning approach to be exact, deep representation learning and fine tuning. And using this merger sample, we conduct further studies to better understand the role of galaxy mergers in galaxy evolution. So we show a number of works we did, including some works on galaxy mergers in the environment and also galaxy mergers related to radio galaxies. So if you are interested, please come to poster P55. Thank you.
Hi, I'm Karen Lee-Waddell, and I'm the director of the OzSRC, which will be part of a global network for compute and data delivery. A design study program was our focus for the past few years, helping research teams find new ways to turn virtual gears. We built pipelines, workflows, and tools connected to a user front end to produce ASCAP and MWA results that soon will transcend. For a detailed summary of the science we currently support, please check out that link in magenta to read our final report. We are now embarking on a long-term program for the OzSRC. It'll take us nearly a decade to build up full capability. With funding and support from the government and our partners listed in that bottom row, we'll work with precursors, the SRC network, and of course, the SKAO. For more information, please check out our website linked through that QR code, and stay tuned because soon we'll be hiring more personnel for our SRC node.
Yeah, I can't rhyme, so it's not happening. I'm Greg Walsh. I'm a PhD candidate at West Virginia University, and my poster, I had to get it. It's P69. It's over there in the corner. So yeah, my project is mainly on a sample of galaxy mergers. So we want to study their radio emission, and really the reason for that is because pulsar timing arrays are going to detect the gravitational wave background, but we still haven't found all but one binary, supermassive black hole binary, that is. So using a bunch of archival radio data and our new VLA high-resolution observations of a sample of 30 late-stage galaxy mergers, we're studying the radio emission holistically from these large kiloparsec scales to the nuclear emission at the centers of their optical nucleus. And then I just sort of extrapolate that towards the NGVLA to see what the capabilities are using the long baseline array compared to the VLBA right now. And we see, of course, great improvements. So if you're interested, right over there in the corner, I'll be here all week. Thank you.
Hi, everybody. My name is Jennifer West. I'm at the Dominion Radio Astrophysical Observatory, the National Research Council of Canada. And my poster is on two of the largest surveys of the polarized radio sky, POSSUM in the Southern Hemisphere and the VLA Sky Survey in the Northern Hemisphere. And so the poster describes both of these surveys have just begun producing data. And so the poster describes some of the early science, which is focused on magnetism science across all scales of our universe. And it also talks about the data management strategy, which is really a prototype for the SK Regional Center approach and how we liaise with the observatory and different data centers, both in Australia and China and in Canada. So my poster is at the back of the room, so come talk to me if you're interested in hearing more.
Hello, everyone. My name is Francisco Tapia. I'm a PhD student at the Institute of Radioastronomy and Astrophysics in Mexico. And I have a poster in which I present my how the radio observation of main sequence stars can help us to understand the temperature structure of the upper atmosphere, and and especially what is the physical mechanism that makes possible the existence of the minimum temperature region. And this region is located between the photosphere and the chromosphere, and it's very important if we want to understand the atmospheric heating and in general the dynamics of the upper atmosphere. Well, and if you are interested in my work, you can go to my website, send me a Slack message, or meet me at the poster. It is P67. And thanks.
No, that's not me either. Ah, there you go. Yeah, I can make it up. Hi, I'm Ben Lewis. I'm the Senior Project Manager for the SKA Mid Telescope. I found out today during Matt's presentation that I'm both highly qualified and highly paid, so I'm going to have a word to my bank about that one. But we're presenting a poster on the status of the SKA Mid Telescope. It's in the back left corner there. You can sort of see where our designs are at the moment, where we're at in the rollout of the telescope. There's some of the physical progress that we've made on site, pictures of the beautiful dishes, and some general engineering stuff. So the slide didn't have much more information. You didn't miss out on anything. Thanks.
Hi, I'm Tony Wong. I'm at the University of Illinois, and the purpose of my poster is to discuss some of the potential synergies between sensitive CO and H1 line observations and the very new and exciting capabilities of JWST to measure infrared emission from the interstellar medium. And so as an example, we look at the 30 Doradus region in the LMC, and you can see here the CO2 to 1 emission in white contours is very well correlated with the pH 3.3 micron feature in green. And we expect the pH emission traces some combination of gas column density and radiation field. But in this region, remarkably, the column density correlation is very good. And so we'd like to, of course, extend this to much lower column densities because this is currently done over a very limited dynamic range in CO brightness. So with the NGVLA, you'd have the sensitivity to push this down to much lower column density with H1 emission. And so there's a lot of opportunities to understand this relationship much better. Okay, thanks.
Hi everyone, I'm Tom Franzen. I'm an operations scientist at SKO, and my collaborators and I have applied dynamical evolution models to 20 giant radio quasars with projected linear sizes greater than 700 kiloparsec to estimate their physical parameters, including the age of the lobes, the jet power, and the ambient medium density. And this required measuring their radial morphologies and spectra across a wide range of frequencies using low-fan VLA data. So we looked at a previously studied correlation between the ambient medium density and the observed radio spectrum for FR2s, and we found that the GRQs form an outlier population with respect to the correlation. They have significantly lower medium densities both at the core radius and in front of the lobe's head, and this result may be important for improving our understanding of what drives the exceptional growth of giants. So if you're interested to find more information, my poster is P19. Thank you.
Okay. Hi, my name is Rajan Chhetri. I'm a postdoc at CSIRO Space and Astronomy. So I think we'll have to wait for my slide to come up. Well, regardless, I thought that I would help you all relax, given that we're all jet lagged. Most of us are jet lagged. I certainly am. And there is drinks coming up shortly. So I thought I'd help you relax by showing you a video of twinkling of things in the sky. And instead of this being twinkling of things in the sky, I was going to show you the twinkling of things in radio sky. And okay. All right. It's not working. Never mind. Okay. So the twinkling is induced by the solar wind. So that is not the twinkling as we see in the sky with our eyes, but this is interplanetary scintillation. And that's what I wanted to show you by identifying these objects that twinkle in the sky at radio frequencies, at low radio frequencies. We can tell which ones are compact at subarcsecond scales, and these objects that are subarcsecond scales are very important for various different scientific endeavors. One of them is going to help us with the SKA low in the sense that we're going to need lots of, here we go, things are twinkling. We're going to need a lot of these compact objects at low frequencies to do multifaceted ionospheric calibration. And we're going to give, this is going to be a very efficient pathway to make that network happen. The other thing that we've found using these twinkling objects is that the population of compact objects changes as we go from high frequency to low frequencies, from being dominated by blazars to peak spectrum objects. And the third thing I would like to impress upon you is that we're developing this technique with the ASCAP telescope, and in doing that, we get such high source densities in the sky that we get to see solar weather transients that we can study with this technique as well. So that's my poster 11. Please come and visit me. Thank you.
Hello, everybody. My name is Roland Kothes. I'm a staff scientist at the Dominion Radio Astrophysical Observatory. Oh, I'm sure I am, but oh, there it is. Yeah, and it's working. So I want to talk about merging single antenna data with interferometer data. Interferometers lack the ability to image large-scale emission structures. So we need observations of single antenna data to merge it with the interferometer. The problem is not only with ASCAP and with Meerkat or the VLA, but also with the future telescopes like the NG VLA and the SKA. So here on the left-hand side, you can see the merging of ASCAP data with Pegasus, the Parkes observations. So it's blinking between the ASCAP, which is here. That's a combined image, and the next one will be the Parkes image. As you can see, it works quite well. The images are printed here or shown here on the same color scale. This is in particular a problem when you want to study the galaxy, nearby galaxies, and magnetic fields. Also, if you want to learn more about it, the techniques we used, the problems we have, and the polarization images, please come to poster piece 37. Thank you.
Only 3 minutes and then you can have a drink. Hello, I'm Maria Grazia Labate. Among all of you that are amazing scientists, I am an engineer, and actually I'm the telescope engineer for the SKA. So I really want to make sure that you will have the best instrument to do your observations. So as you know, we already started the construction activities, as Phil mentioned this morning. And early next year, we will start deploying the first antennas on site. So in my poster, I want to provide you with the status of the project. I want to show you the results that we are having from the station prototypes that are already on site, and also share with you some highlights of the architecture. So my poster is 39 right there, and get ready to do observation willow. Cheers.
Hey everyone, my name is Oleg Smirnov. I'm from Rhodes University in Sarajevo.
And my poster is P64 right here by the exit. You cannot possibly miss it. My poster was supposed to be this animation. I thought of printing it in this old school, flip book form, but couldn't find a printer who would cooperate. This is an animation made from meerkat data. I like to call it astronomer's bingo because there are a lot of interesting objects on this animation, and for some reason, most astronomers actually struggle to name them, particularly optical ones. I don't know, are there any optical astronomers in the audience? So I'm posing you a bingo question. How many interesting objects can you identify in this animation? You can use this QR code on here or on my poster to view it on your phone. If you've got answers, please come to my poster. On a more serious note, this is meant to highlight, Brian mentioned earlier today that Meerkat is a fantastic instrument for snapshots, for snapshot imaging. And so I think my poster is meant to highlight that and also to whet the appetite for what's going to come next with SKA and NGVLA. Thanks very much. And now I give you a bonus speaker.
Good evening. I can say good evening now because I stand between you and the reception. My name is David DeBoer from the University of California, Berkeley. I don't have a poster, and I stand between you and the reception, but on the positive side, I am here on behalf of the Breakthrough Listen initiatives to invite you to the reception. For those of you that don't know what Breakthrough Listen is, it represents humanity's most wide-ranging and sensitive search for extrasolar technological signals, I gotta say it right, or technosignatures. And also it strives to engender a community and develop a community that will continue this technosignature science into the future. So the reception, I'm not gonna talk long, the reception is just upstairs. It starts immediately as we're dismissed from this room. You can take the steps over in the corner past the lounge. You can take the elevator to R and go up and around, and it is in the ocean view room. You should see it. It's in the corner, kind of past where you spent so much time yesterday, if you checked in at the lounge, over in that corner, one floor up. So on behalf of Breakthrough Listen, I hope you enjoy the reception. There are appetizers, and in honor of our local hosts, there is poutine. And there's wine and beer and stuff like that. So we look forward to seeing you up there, and thank you very much.